You're listening to the Common Descent Podcast.
Hello, David.
Hello, Will.
And hello, listeners. Welcome to episode 39.
Ooh, hey, that's a multiple of 13.
Yeah, it is.
There you go. There's your random numerology for the day.
That's something you know now.
That's
Those are one of my favorite jokes on the internet.
I'm a big fan of 13.
That's something you know now. Today's episode is for a triplicate of a prime number, a weird episode. I think that's fitting.
I think so.
This episode is on speculative evolution.
What?
Yeah, what? So I'm so excited for this episode. This is a concept I'm very happy to talk about. Speculative evolution is it's mostly just a thought experiment of taking an organism or a situation and hypothetically thinking through what would be the path of evolution or what would be the likely outcome of that situation. So basically saying, how would an organism or a known organism, so new thing we already know, evolve if blank were the case, if it were on an alien planet, if this happened, if something else didn't happen,
Yes.
or if it were able to continue to evolve. And it's just a thought experiment of past, present, future scenarios. It is a very unusual subject, especially compared to a lot of our others. Why we're talking about it is that it's actually a really interesting exercise in that critical thinking that is so important in sciences, especially fields like paleontology.
It's also very popular.
It is very popular and fun.
And it's very fun. And that's the other thing. It's just a ton of fun.
We'll definitely look into those things. The big reason why we're talking about it is because it was requested 3 times.
Ooh.
Yeah. We got 3 requests that dealt with this subject. One by Mellow Dinosaur. On our Podbean, in fact. That is now 1/2 of the people who used our Podbean. So
Excellent.
And we had Liz on Twitter request the same thing. And then we had a similar request by Lydia for theoretical exoevolution, which we will also touch on. Same concept, just a specific aspect.
Right.
Thank you for all the requests.
Yes, thanks to we're starting to get topics that haven't just been requested, have been requested multiple times, which
That
is
we're
a lot
able
of
to
fun.
tally, that we're able to keep up with. And so and boy, what a fun one to be a popular one. In this episode, we'll be discussing the concept of this weird subject and some of its main examples and uses in the real world and in scientific fields. There are some practical aspects to this, seemingly just for fun concept, but we'll also be talking about some of the people who are major players within this practice. But of course, before that, we got some announcements, and then after that, we got news. So, for announcements, not a lot today, but a big one, a very exciting one, because, as many of you already know, we have a Patreon, and if our patrons sign up, and if they sign up at a certain level, they can get certain things, one of which being a shout-out. So, shout-out to Jim White. Welcome to the Patreon.
Thanks, Jim.
Yeah!
Thanks for joining us.
Absolutely. So,
also, as of this recording, Jim, we've just finished reading your email. So
yes,
you'll get a response to that before this episode comes out. But thanks for that.
Absolutely. That's it for the announcements. Boom, bam, done.
Quick announcements today.
That means it is time for the news.
It is news time. What's new?
Every episode, we go through some of the recent scientific articles on aspects and its discoveries and research in mostly paleo, but sometimes other fields, and report on them for the beginning of our episodes because we feel it's important to be up to date. And David, would you like to be the first to bring us up to date?
Sure thing. I'm going to talk about dogs.
Dogs?
Specifically, Native American dogs. because it turns out there was a group of dogs, domesticated dogs, that lived in North America thousands of years ago, and no one is quite sure what happened to them.
Huh.
This is a new study in the journal Science by, and I am just so sorry. There's no way I'm going to get this right. I'm going to do my very best. Meyer ni Lithlebert, once again, I'm very sorry, et al. In the Journal of Science.
Many apologies.
I'm so sorry. We're going to put it in the blog post. I link to it. You can go check it out. You can see this name. You can try for yourself. There are about 50 authors on this paper. One of them is Chris Widga.
Hey.
Currently a curator at the world-famous Gray Fossil site.
Cool.
There's also a great popular article for non-technical folks at The Atlantic by Ed Yong. So we'll put that in the blog post as well. Humans arrived in North America by around 14,000 years ago, and domesticated dogs arrived in North America by around 9,000 years ago. The humans eventually brought them over, and so there were these essentially Native American dogs, these dogs living with the first humans in North America, but not much has been known about what happened to these dogs. Were they completely wiped out? Are they still around somewhere? Like, is there genetic remnants? Are there descendants still around somewhere in modern day dogs? There are a couple of breeds of dog that are still around today that some have claimed are descendants of the earliest dogs in North America. This study attempted to answer these questions by analyzing the DNA from over 70 archaeological dog remains. What they found is that the dogs that were here in North America were in fact descendants of Asian ancestors. So they did not evolve from North American wolves. They did evolve from earlier Asian domesticated dogs who themselves evolved from wolves over in Eurasia.
Oh, that's cool.
They also found that this was a completely unique lineage, that the lineage that lived in North America was a separate family group of dogs, and that they appear to have completely vanished, presumably around the time that Europeans arrived in North America.
I don't like where this is going.
Well, that's the end of that story, but one can speculate that the Europeans arrived and through some combination of disease or intentional persecution or other means completely wiped out the Native Americans, dogs.
There's a very sad Homeward Bound style movie to be made.
Yeah.
Oh gosh.
So this does appear to have disappeared. When they examined modern dog DNA from several thousand individuals of modern dogs to look for remnants of the DNA of this lineage of dogs, they found tiny traces in certain Arctic dog breeds, which are probably their close relatives. Not necessarily descendants from them, but relatives who would have shared some of their genetic material. But most dogs don't have any remnants, any sign of these ancient dogs. They appear to have split off, had their heyday in, early North America, and then vanished, replaced by our modern day dogs who were brought over from elsewhere.
That's fascinating me. It is very surprising considering how prolific dogs are for invading an like the fact that dingoes are not part of Australia wildlife. They're dogs that got out. They were introduced as domesticated dogs, and then they kept breeding and people kept letting them run away, and they now are just there. The fact that didn't happen with these, that they did not just blend in with the ecosystem or interbreed, that's a big part of a lot of dogs.
What surprises me is that they didn't get mixed in with modern dogs.
Yeah,
at least according to this study.
Mutts that were formed.
Yeah.
That's wow. Huh.
Yeah. The added twist to this is that
there's a twist.
There is a twist. They did find a very close living relative of these dogs, but it is not a dog. Some of you may be familiar with what is called CTVT, which stands for canine transmissible venereal tumor. which is a form of contagious cancer that can spread through dogs. Because this is a form of cancer, it has its own genetic history.
Yeah.
It's got its own genetic lineage, which is dog DNA, because it's formed in dogs, but it's got its separate history. One of the parts of this study was an analysis of DNA of this particular kind of tumor, this cancer, that concluded, first, that it arose in one dog around 8,000 years ago, somewhere in Asia. That's where the disease kicked off and then spread across dog populations ever since.
A true patient zero.
Yes. And that this line of cancer is the closest living relative to these extinct North American dogs. Because the dog from which it first formed was a close relative of this extinct lineage.
See, now that makes it sound like the ancient dogs cursed modern dogs.
Yes, they left this genetic curse behind.
Before we go, I leave this for you.
Yes, a pox on both your houses.
That's really cool.
Oh no, it's super fun. And in the article, Ed quotes some of the authors commenting on, like, what are the odds that we would find, like, this is the closest relative, is this disease that spawned off of a cousin of these dogs.
Poetic paleontology. That's cool.
Now, at the end of the Atlantic article, Ed does describe a whole bunch of the complications with this. DNA studies are often fraught with uncertainty because of mixture between lineages. So the exact timing and the exact locations of certain things are often debated. So this is probably not the end of the story, but at least for now, some very intriguing new insights into the history of dogs over here in the New World.
Very cool. It's neat to look into the history of a domesticated group and find that it is equally complex to many of the natural groups that are studied.
It is.
Neat.
Domestication's episode 27, by the way. Go enjoy.
David Spark notes.
Yes.
My first piece of news actually also deals with ancient people, funnily enough.
Aha.
We're diverting for our unusual episode, this topic episode.
Yes.
My first piece of news deals with hunting in Neanderthals and evidence found via lesions in bones of two extinct deer that show they hunted in a way that's not quite what you might expect.
Ooh.
Very interesting hunting strategies.
I'm intrigued.
Indeed, we have the setup. But first, this research is published in Nature, Ecology, and Evolution by Sabine Godzinski-Windhauser et al. And the article I'm reading is from the conversation by Annemieke Milks. So, Neanderthals being an ancient species of human, there have been questions as to many of their behaviors, since those don't fossilize all the time, and hunting has been one of them. It has been thought that they had complex hunting tool use and behavior, but not a lot of evidence for it. The hypotheses of the researchers who study this have thought that probably back to almost 500,000 years ago, Neanderthals most likely were hunting with tools, but direct evidence has been lacking. The other part of it that is in question, even though tools have been found, how they're being specifically used may not be the same as how we use them. So that's seems like a weird question to ask, but just because they had spears doesn't mean they were for attack. They may have been for defense. And were they using the spear the same way? This bit of evidence, this new discovery, gives insight into that. And this discovery is in the form of two specimens of fallow deer, an extinct species that was found in Germany and dates back to about 120,000 years old. These deers, the skeletons, mainly the hips, the bones of the hip, sported lesions, injuries, puncture wounds that were positive matches to spears, and ID'd to spears that would have been used by Neanderthals for the area that they were in.
Interesting. The murder weapons.
And the author actually quotes it as the smoking gun.
Nice.
And so this is literally a smoking gun scenario kind of thing. This is, first off, the oldest discovery of definitely defined hunting lesions of this kind to date.
Oh, that's cool.
Yeah, so we have an oldest on the book. That's always cool. The injuries were analyzed in a very unique way. Going back to that smoking gun analogy, they were analyzed with motion sensor technology to determine the angle and speed of the impact.
Oh, it's like ballistics.
Yes, it's ballistics. That's exactly
so cool.
what it is. And the main question here is, were they throwing the spear or jabbing the spear? Because those are the two main ways one uses a spear.
Was this a strength check or a dexterity check?
Yes, exactly. And what they found is that the angle of the puncture of the lesion was low, and that it was not at a high-speed impact.
So it wasn't an arcing throw.
It suggests an underhand thrust. So holding the spear at your hip and thrusting like a pitchfork.
Mm-hmm.
And suggests a couple of side traits to the hunters. First off, to thrust a spear into a deer, you must be nearby it.
Yes.
You can't have a 20-foot spear, so you need to have gotten in close, which suggests that they were planning the attack and able to navigate in close. This could be stealth or planning ahead, and most likely teamwork. And so this suggests, all of this together, suggests complex hunting behavior.
And up-close hunting behavior,
Up-close hunting behavior. Suggests that Neanderthals were sophisticated hunters, not just lobbing things at their prey. They were planning ahead and coming in for a surgical strike. This is supported by the fact that the area around, this was a lake that they found these fossils at, the area around this lake is identified to be dense canopy. So closed top canopy, not much light getting through, very dense forest.
Okay, not great for hunting at a distance.
No, it is not, and also is notorious for human hunter and gatherer survival. Even today, it is one of the harder places for humans to just thrive in, but the evidence shows that Neanderthals were thriving here. So these were skilled survivors, skilled hunters.
Very cool.
Yeah, it's a neat to kind of recreate a literal crime scene with a weapon.
It's always really fun to learn about, this almost gets into what we'll talk a little bit about in this episode, is that, we have this tendency in archaeology to find a tool and assume it was being used the way that we would use it.
Yes.
Setting aside the question of understanding how even we would use it, but to then think, well, this was a different species with different physical capabilities. And it always goes back to my analogy that I use, and I said this in episode 18, Human Evolution, when we talked about this, that I like thinking of the Pleistocene, the late Pleistocene, with all its different hominin species, like Middle Earth.
Yes, exactly.
Like, how do elves hunt versus how humans hunt versus how dwarves hunt? Like, who knows how different Neanderthal approaches might have been from humans, from the Denisovans, from whatever else. And to get these little glimpses of it is always really, really fun.
It would be kind of like, to me, to take a tool from a specific trade. The example I'm going to use is not a specific trade, but it's the first one that came to mind. One of those fancy folding wine openers where like everything folds inside of it, and giving it to a bunch of different people, from an expert wine taster to us who do not drink, and saying, all right, use this correctly.
Yes,
and not giving no more context. It's not laying next to a bottle of wine. It is, here's a tool, use it as it is meant to be used. To me, it looks like a very lackluster pocket knife. It's got a blade on it. It's got a corkscrew on it. It's got a bottle opener on it. So like, all right, I mean, guess I'll carry it around with me in case I ever need one of these three things. But and so we might use it completely wrong just because we don't have that knowledge. So interpretation is very, very based on your preconceptions.
Yeah, and it's just always fun to learn new things about Neanderthals.
It really is.
Our cousins. Well, I'm going to shift gears a little bit with my next bit of news. More ancient DNA studies, but we're going to bring up a topic that doesn't get talked about nearly enough on this podcast.
What would that be?
Testicles.
I saw this news piece and was so excited.
Oh, we're going to talk about it. Today, most mammals have testicles. Male mammals, at least. About half of all mammals have testicles.
Surprise study finds.
Yeah, surprise study. Only half of all mammals have testicles. No, that's not what it is. Most mammal species, in the males, their testicles develop near the kidneys, and then later in life, often by the time males are born, they descend to a lower location, lower abdomen, or out into the scrotum itself, which is external. This is a study that investigated why some mammals don't do that and how that evolved. This is a study by Virag Sharma et al. In PLOS ONE, and there is a wonderful article about it by Steph Yin at the New York Times. Now, like I said, this is common across all mammals, that the testicles drop. A common descent, if you will. There are a few lineages of mammals that do not do this. Elephants do not. Manatees, rock hyraxes, elephant shrews, a few others. They instead keep the testicles their whole lives up near the kidneys. This is a condition called testicandy, the lack of a descent of the testicles. All of these animals belong to a group called the Afrotheres, so they're all related to each other fairly closely. But this raises all sorts of questions. Is this something that they lost? Is it something that Afrotherians lost once? Or is this something that the rest of mammals evolved? What was the ancestral condition?
Yes.
Was the ancestral condition testicandy, or was it the more familiar descent of the testicles into the presumably more advantageous position, unless you're a kangaroo hopping over barbed wire fences? So this study attempted to investigate this by looking at DNA across mammalian species. There are two genes that they focused in on, two bits of genetic code that are known to be important in this process. The two genes are named the same way genes are always named, with the same way we name like exoplanets. It's just letters and numbers. These are called RXFP2 and INSL3.
Sounds like programs, which is fitting.
When you churn these off in mice, in male mice, the testes don't descend.
So sure we know, appreciate
greatly. They're all sopranos. We know that this is important in this process. When they examined the Afrotherian lineages, they found that in 4 separate lineages that retain the testicles inside the body, high up by the kidneys, they didn't find that these genes were missing. They found that these genes were broken. That they had the genes, but each lineage had experienced some sort of mutation that broke the genes. Which is really interesting because, first of all, it suggests the descent of the testicles is a ancestral feature.
Yes.
These genes were around early on, and these lineages lost them. Even more intriguing, they were able to calculate the timing of those mutations using molecular clock analysis, which we've mentioned briefly before in episodes 10 and also episode 34. And they estimated that the breakage of these genes happened at different times in the different lineages.
That's weird.
And that the mutations that caused the deactivation were different in the different lineages, which suggests that this happened 4 separate times.
So something about this group made them prone.
Perhaps. But even and also that all of them were estimated to have happened after Afrotheres split away from the rest of mammals.
Okay.
Which again suggests ancestral feature lost independently in at least 4 different lineages. But elephants, for example, and rock hyraxes also, I believe, don't have these broken versions of the genes, but also exhibit testicandy, where the testicles don't descend further.
I don't want to be left out. Everyone else in our group is doing it.
So they found another way to evolve this feature that we don't know of yet. So for some reason, at least like 6 times across the Afrotheres, in manatees, elephants, tenrecs, elephant shrews, golden moles, rock hyraxes, they appear to have independently evolved this feature of retaining the testicles up by the kidneys for some combination of reasons. And at least 4 of them did it by breaking these genes after inheriting this trait from their ancestors.
As if this wasn't a weird enough group to begin with. Like,
right?
When you look up the lineup of a lot of other groups, you're like, all right, mustelids, yeah, you have some different shapes, but you're all like short and mean.
You're all weasels.
Yeah. But then you look at this one, it's like, all right, you're huge and your nose is an arm. You swim, and you're like a rabbit, but with like,
yep.
What? And you all got rid of your hanging testicles,
but not all Afrotheres, because some, like aardvarks, still do it.
Of course they do.
Yeah,
of course they do. Oh my god!
And it also raises the question of why. Clearly, this is a useful feature across the mammalian family tree to descend, to put them out in the scrotum or at least lower in the abdomen. Presumably, one of the benefits of retaining it up in your body wall is not having them just dangling around outside your body where they could get damaged.
Whanged. Yeah, that's...
I imagine that the Afrotheres look upon all the other mammals and they're like, hey, we're supposed to keep these safe. Yeah. And you've all really dropped the ball on this one.
You're all going to feel real dumb. It's interesting because it's obviously not a huge mistake to undescend because these animals have been around for quite some time. So they're surviving, but they are all very interesting animals in their environment. Like many of them have very specific niches that they fill and specific ranges. A lot of them are definitely much more vulnerable to human activity, which it's a very interesting group with some interesting similarities and differences, and the fact that this is one of those similarities is very unique. I don't know what to make of it, but that's super weird and cool.
Not a lot of conclusions to be drawn just yet, except that they all did it, and it's kind of weird, and some of them did it the same way. But there's a little bit of testicle evolution for everybody. I don't think we've talked about testicle evolution ever in 38 episodes. So.
No, I mean, the closest we came was clasper evolution for placoderms. Which
that's true.
It's grazing, but not quite there.
We did talk a fair bit about sex in episode 18B.
Yes, we did.
But there you go, everybody. Testicles.
All right, well, my next one is not nearly as testicle oriented. I apologize ahead of time.
Well, then what's even the point?
What's the point? I know. It's boy, I hate to follow that act. This article, this is actually a modern study on modern insects and plants with a very interesting feature to their life process. I found it too interesting to pass up. This is about insects that are feeding on rice, the brown plant hopper, and the fact that the quality of the rice tells the insects when to leave. And not only when to leave, but when to develop the ability to leave.
Huh.
This is research done by Shinda Lin et al. In the Proceedings of the National Academy of Sciences. And the article I'm reading is the press release from phys.org, put out by Washington State University. And it deals with the research on the fact that the crop pest, the brown plant hopper, which is the scourge of rice crops across their range, these are just little, not grasshoppers, but very similar little hopping insects that jump from plant to plant, feed on the plants, destroy a lot of crop, cost a lot to the people growing the crop, but also threaten one of the biggest sources of food for some of the most populated countries in the world. So kind of a big deal for them to deal with. The juvenile plant hopper feeds on the plants and then develops into its adult phase. And it has one of 2 phases. And this research found an interesting thing about why it switches between these 2 phases. The most common phase is short-winged, like the juvenile, and big ovaried. The females have large ovaries for making lots of babies. And so these are plant hoppers that are sitting still and pumping out babies to eat more rice. And so they are sticking around. The other form is a long-winged version with small ovaries, no longer having babies, but getting ready to leave, travel long distances.
And a weight-saving feature.
Yes, exactly. So you have the stay-at-home adult and the homestead. That's what I'm looking for. The homestead adult and the world traveler adult. But they found that there's an interesting trigger between these, because there's reasons that insects go between the two adult phases. There's not just randomness, and there's high risk if they choose the wrong one. If you choose the stay-at-home, have babies option, and the food runs out, you starve.
Mm-hmm.
If you choose the big wings option, there's still plenty of food. You waste energy searching for new food when there was food to be had. So the plants are what tell these insects to move. The plants, as rice gets older, develops glucose buildup, the sugary plant material that plants make while they are photosynthesizing. And it begins to build up in these older plants as they're getting ready to die, because plants do have life cycles. This buildup in glucose is what tells the juvenile plant hoppers to develop large wings. Cool. So basically, as soon as they are able to tell that the plants are, and it's not like they're making a conscious choice, but as soon as the insects can sense that the plants are beginning to age and potentially die soon, they develop the wings to get out and go and find new plants. The reason this is fascinating for the scientists studying it is that glucose is the only trigger so far as they found, and that's really weird to affect a developmental change in an insect. They're often very complex with lots of things being able to adjust in, there being lots of variables and factors to it, but it appeared to just be glucose. And to confirm, they took a juvenile plant hopper, injected it with glucose, and large wings, small ovaries.
Cool.
That's it. So very simple trigger for this big change in their life, which could mean a potential way to fight these pests and trick them into developing large wings early and leave. Straightforward research, but it's interesting. The fact that you could develop into a different kind of adult just dependent on basically how much sugar you're eating.
Yeah, and I always like to imagine how this factors into evolution. Like, obviously the evolution of the trigger is interesting, but also that now you have two vastly different phenotypes.
Yes, you
right?
do.
Like, you have two different versions of an adult, which offer two different tool sets for natural selection to fool around with.
I mean, it's two completely different lifestyles of traveling and searching for food and just sitting and munching, and like an aphid, just producing babies like a factory.
Yeah, and it makes me wonder, like, at what does it take to retain that? Like, a species that exists in two different forms, how easy is it to then tip that over and go, all right, well, we're just abandoning one of those forms. We're going to evolve into a species that just does one of those now.
And if that can happen, it could happen either way or both ways. And you could have a split because of that, which is very interesting.
All very interesting. But now I worry we're just speculating.
Oh, that's something we should think more on.
Oh, we should talk about it.
But before we talk about it, I have one extra little bonus piece of news. Very, very small, very, very quick.
What?
This is not even a normal news article. I literally came across this today while I was at work, and I could not say it on the podcast. I know that's a double negative, but that's how excited I am. This is about an alligator named Mr. Stubbs, who did not have a tail and now does.
The name kills me. That's great.
Mr. Stubbs. This is
they
from
call me Mr.
news
Stubbs.
article. They call. This is from a news article on Fox 6 Now. It is a alligator who made his way to Phoenix Herpetological Society in Arizona to rehab the fact that he had lost his tail.
Poor guy.
Most likely from a fight with another alligator. It's a smaller alligator. It looked to only be like 4-ish feet long, so not huge. but it was completely missing the tail, just basically a stump right behind the back legs. But it recently got a prosthetic tail. So that it could swim and move around, and they say he's able to move around just like a normal alligator. The big issue is that if they put him in a habitat where the water was deep at all, he couldn't get up and he would flip over. He would float wrong, and he couldn't right himself. But now he has a lovely plastic tail.
That's awesome. I'm gonna have to keep a stockpile of cool snake facts because snakes are never in the news. Like, there's never cool snake news. It's always just some guy found a snake and then it almost bit him, and by almost bit him we mean he found it in his bathroom and called the police about it.
Yeah,
but I'm gonna have to you're gonna keep bringing in these gator things.
I know. Yeah, you're very right. There's a very biased swing to the nature news.
Just so that everybody knows, there are snakes whose lower jaws work like saloon doors that swing in and out really, really fast to suck up maggots.
It looks like a cartoon version of someone eating, just like brrr.
Enjoy.
It's adorable.
That's my anti-alligator snake fact. I gotta have something.
We must balance the scales.
Perfectly balanced, as all things should be. Hey, let's talk about this topic.
Absolutely, we should. So we are going to discuss speculative evolution, what it is, and why it's awesome. So, our main subject today, speculative evolution. Now, we've already given a little bit of a intro to it, but to give you a bit firmer grasp on this concept, speculative evolution, as Wikipedia defines it, because I think this is actually a fairly good way to say it, is a genre of speculative fiction and an artistic movement focused on hypothetical scenarios in the evolution of life.
That sounds pretty good.
It's pretty good. It's pretty concise way to say it. This is basically the concept of taking what ifs. If anyone here listening is a Marvel fan, the what if comics in Marvel, where they say, all right, this is what happened in this story that you just read, but what if this guy had won? This guy had died. This lady had gone with the bad guy instead of the good guy, or so-and-so, kept whatever, all these different scenarios.
Well, you get the same thing with historical fiction, right? Like, what if
the Nazis something, usually.
Yes, yeah, exactly. That's what I was trying to think of. What if the Nazis blank?
Yep, that's
what
usually...
if they won World War II? What if Caesar hadn't been killed? This kind of stuff.
What if Russia got to the moon first? Lots of those, some small, some big. This is doing that, but on an evolutionary concept. You'll also hear this called speculative biology or zoology. Mm-hmm. Basically focusing more on the anatomy side or the environmental side or things like that instead of just the evolutionary. But they're all in the same speculative life history of whatever animal you're talking about.
It's a version of applying real-world understanding to fictional scenarios. So in the same way that when people do like, what would this alien planet look like? Yeah, what would the geology? There was like a geology of Game of Thrones where people are like, let's analyze. We actually did this at an event one time at ETSU where we said, what's the geologic history of Skyrim?
Yes.
Based on the rock, like, we're going to interpret these rocks as though they were actually laid down. You're applying real-world scientific expertise to answer fictional hypothetical questions.
This is a category known as hard science fiction. Basically, science fiction with a focus on or emphasis on scientific accuracy, getting as close to real science as you can while still being sci-fi. And the main thing to take away from speculative evolution is that this is not just making up animals. This is not playing Spore and just making an animal you want to make. Even though that's kind of how that game was, advertised, is that you will evolve you don't really. You could be a flying animal one moment and then a legless animal the next moment and then have 6 legs. So that is just making up animals, which is fun. This is taking concepts that we know in true science and either how would you get to the thing you've already made or what answer would you lead to with the scenario you have. A great example of this, Dougal Dixon, a man who has done quite a bit of speculative evolution, we'll get into his history in just a moment, at one point has predatory rats, and they have sharp teeth, but still being from a rodent lineage, only 2 front teeth that have just sharpened like canines. That's what we're getting at. You can...
You're applying real-world restrictions.
Exactly. And so it's a extremely good thought experiment and exercise. And 2 of the names that you will see pop up with it most often, modern days, is Darren Naish. Many of you may recognize that name, one of the main authors of the Tetrapod Zoology blog.
Well, he's the main author of the blog and one of the hosts.
That's what
of
it is.
The Tetrapod Zoology podcast.
Yes.
Yep.
Thank you.
Shout out to the Tetrapod Zoology podcast.
Absolutely. And on his blog, he discusses many, many scientific concepts. One of the ones that pops up very regularly, a passion of his, is speculative zoology, as he often titles his articles. Discussing potential ones, discussing its role and how it's being seen and how it's been used, and all its aspects. We'll have lots of links to his stuff. So you'll hear a lot of the things we talk about today can be referenced back to his articles, because he's by far the one nowadays writing the most about it. But the big name that we've already dropped is Dougal Dixon. This man is considered by many to be the founder of the concept of speculative evolution. Not the first one to ever do any of it, but the first one to really establish it as a movement, as a concept. Now, this is a British author who's still around today, still actually writing today, and has written a number of books on the subject. The big ones that you'll typically hear about are After Man from 1981, The New Dinosaurs, 1988, Man After Man in 1990. He also worked on the series The Future is Wild, which we'll discuss a little bit later on, and wrote a book by the same name. And the most recent one is Green World in 2010. All of these dealing with specific concept. After Man is future wildlife on Earth, what might become of some of these organisms. The New Dinosaurs are basically, what if the dinosaurs had not gone extinct, or what might have also evolved that we haven't found. Man After Man deals with how our effects change the evolutionary paths. And the whole concept in these is what ifs for evolution. And these are really the first books to do this as the focus, and now is a very popular movement today. There's actually an interview between Naish and Dixon, and he describes what one of his inspirations were. And I really love this because one of the original forms of this, just before this terminology was a thing, is what inspired him when he was younger, is H.G. Wells' The Time Machine.
Oh, interesting.
And for anyone who does not know the basic story of The Time Machine, this is about a European scientist, Victorian era, that creates a time machine, a chair with mechanics and devices and levers to move forward and backward in time. And for scientific exploration, moves forward and discovers a Earth populated by 2 different species of human, one above ground, one below ground, and that humans have diverted and now have new roles in the environment. I'm not going to give it all away because it's an interesting book and you should read it, but it is old, so beware of spoilers. But this was speculative evolution. This was what could happen to people if whatever scenario it was that H.G. Wells had in his mind that caused this diversion happened. And there's even others where he goes even further and finds large crabs feeding off of giant fungi and no other seeable, and basically this sparked the idea. The other thing that sparked it, I really love this, is he quoted his father that there was, when he was slightly older, a time where they were watching some special on TV about tiger conservation. And as he puts it, his dad turned to him and said, "Why save the tigers? The tiger will become extinct. Everything becomes extinct. Other things evolve." And he said at the time, this seemed like a very unhelpful point of view. But then eventually it clicked. Yeah, everything eventually goes extinct and things take their place. And this kind of sparked that question, what things might take the place of animals today.
Yeah.
And these formed that concept of how can things potentially end up.
And this is one of those, if you frequent, as I do, the parts of the internet where people are encouraged to just ask questions of curiosity, two of the most common questions I see related to evolution and paleontology are, what will X evolve into?
Yep.
And what if X had never gone extinct?
Yeah, we got a question on our survey asking if we could hypothesize or postulate the future evolution of snakes and crocs.
Yep. It also comes up in what if the dinosaurs were still around is interesting, but what will evolution do in the future in a rapidly changing world is also a very interesting, valid question.
Yeah, potentially critical for some animals and ecosystems. So
Indeed.
This concept, now the why behind this concept, why are we discussing it, why is it important, goes into the fact, the main aspect is that it is critical thinking. It is real, it practices and it nurtures critical thinking, very much the same kind of critical thinking of many sciences. And it also helps kind of broaden our views as to what is possible in evolution and keeps us from getting stuck in one mindset. But one of the big reasons, as we've already said a few times, is it's fun.
I think that's the most important.
Absolutely.
That's the kick. And for some people might be listening to this out there, probably not many in our audience, I would imagine, but there could be some people out there going, why? That sounds weird. That
sounds like a
weird
waste of
thing
time
to spend your time doing. But if you are the kind of person who, like your humble hosts, likes to just make up stuff.
Yes.
Like games and creatures and characters and just fun things. And you're also kind of sciencey minded. It's super fun to apply your knowledge to something fantastical and something that's fictional and fun.
I have a quote from Darren Naish that sums it up pretty well. He says, I quote, "If your mind isn't racing with possibilities, crazy ideas, speculations, and things you wish you knew but never will when you think about animal evolution, then maybe you're doing it wrong." And that pretty much...
Darren's a cool guy.
That pretty much sums it up, is that if you look at the vast array of life that has been on Earth and is on Earth, and don't go, yes, but why not aquatic bats? Then what are you doing?
Then speculative evolution is not for you.
No, exactly.
It's a gift and it's a burden. It's the reason that it takes me so long to come up with landscapes if I'm coming up with a D&D setting.
Yeah.
Because there's a part of my brain that goes, would the mountains really be there? Shut up.
Yep.
This is a fantasy game. A wizard did it.
Yep, absolutely.
But it's just that kind of wondering and curiosity is really tantalizing.
Well, it's the same things that happen when you're watching a movie and you go, I feel like you've shot more bullets than that gun has.
Or when I watched Westworld,
yeah,
and all I could keep thinking is are all those animals robots, or are they native? Did you introduce those animals? Is there a thriving ecosystem here?
It's just, the animals are just walking around going, I don't know what's wrong with these people.
Oh, that guy keeps walking the same path.
It's when you're trying to answer those questions, but also trying to answer potential questions. There's some really popular concepts that you'll see pop up a lot in speculate. If you just Google it, there's some really popular concepts, and there's even some kind of movements. Probably the most common in the paleo mindset is, what if dinosaurs didn't die off? What if the KPG extinction never happened, or at least didn't happen the way it did, or when it did? That's probably the one that you'll see pop up most frequently. There's actually a movement for this called the Speculative Dinosaur Project. Started in 2001. It's no longer really a thing anymore, but you can find things that still are within it. And it was just kind of a collective, collaborative movement by paleo artists and scientists to put forth ideas of how could hadrosaurs, the duck-billed dinosaurs, diversify had they not been wiped out? And just interesting concepts. One that I found while doing my research for this that you will particularly like, David, is one called the Squaw Mosaic Project.
I am so happy you mentioned it, sir. It was my one thing that I was like, this has to be mentioned.
Yes, indeed.
That's something that Darren Naish has worked on. The Squamazoic. What if instead of the mammals taking over after the dinosaurs, the herps did?
Yes.
The squamates and such. And yeah, they just all these cool ideas of like, all right, if lizards and snakes were the ones that rose to dominance, and I've fantastical ideas about the aquatic versions they might evolve and the volant versions they might evolve.
Well, like the question of what does a large herbivorous lizard look like? How would lizards develop into a big grazing creature? Or would they do something weird and different? One of the best things with speculative evolution, and this is why I love people who make fan art of other things, is nature artists and paleo artists draw some of the coolest stuff for speculative evolution concepts.
Yeah, well, that's the speculative evolution concept is just loaded with skilled artists.
Yes, it is.
Who know what they're doing and are having a great time.
Another really big one that you see pop up very often, that's a very popular question, is we have flightless birds. Why not flightless bats? And what would that look like?
Yeah.
You see that pop up a lot in a lot of things. We'll mention one in a more detail in a little bit, but
I bet we will.
Yeah, we will.
I wonder if it's the same one I'm thinking of. We will find out.
I'm pretty sure it is. And so like those it's also very big for not just what if so and so won and so didn't, but there's also those questions of we have flightless birds and we have flightless insects and we have, we see a lot of those things where losing flight is fine. Why no bats doing that?
Yeah. Or like these animals have become aquatic. Why don't we have fully aquatic birds?
Yeah, exactly.
Like marine aquatic, birds that spend their whole lives under the water, like dolphins do.
And those kind of questions are valid. That's a scientific question that scientists are trying to ask. Speculative evolution gives kind of a way to exercise those brain muscles on those questions, which is very cool.
Another really popular way to apply speculative evolution is to pick an endpoint and then say, how would we get that?
Yes, and that's probably one of my favorites, is trying to figure out an evolutionary and biological answer to something.
Yes, like how would xenomorphs evolve naturally? How would you get... This comes up all the time with Pokemon.
Yes, there's Pokemon anatomy.
How would you actually... What would the anatomy look like? How would you evolve this? What is the evolutionary history of the Pokemon family tree?
That's, I think one of my favorite things I ever saw was a phylogenetic tree of life for Pokemon based on morphology, since we can't do Pokemon DNA. At least not yet.
Not yet. We'll see. Get some of that amber.
Yes. And
Old amber.
And went through and created transitional forms between different groups and categorized them by their morphology and how similar they were. And went, all right, these probably have a common... It's super cool. One of the aspects of speculative evolution that leads nicely from the how do you make a Pokemon or other animal with evolutionary processes is speculative evolution in the media. How it gets portrayed and stuff. There are some that do it directly. There's 3 main documentaries that pop up, or, not mockumentaries, but there's another term, pseudo-documentary.
Yeah.
There's another term for them, but docufiction, I think, is what I'm looking for.
That's
right. The Future is Wild, Alien Planet, and Dragons, A Fantasy Made Real are not the only 3, but they're the 3 good ones that I'm going to suggest if you go look up.
I've seen 2 of those. I have not seen the middle one.
They're quite good. Alien Planet is fun. It's a little bit more shooting from the hip, but it's worth it if only for the robot probes. Those are really cool.
Cool.
So
I remember The Future is Wild. I remember when that came out.
So basically, each of these Future is Wild, which Dixon worked on, was one of the people acting to help think of things, is just, it jumps through chunks of time into the future, humans have left Earth to colonize some unknown region, and we send a probe back to observe Earth and see different lineages of animals going into different evolutionary routes. You get, some of them are seem kind of silly, like you get the flish, which are flying fish. Literally flying fish. But then you get some interesting ones like terrestrial cephalopods.
Yeah,
and some
or
cool
like
stuff.
I think they call them gannet whales.
Gannet whales,
which were birds that had evolved to live like seals.
Yes.
And I think that, was it that like mammals had gone extinct at some point?
Yeah,
or
like
something? Like
the
they
mammals
were like certain things go extinct and others evolved to take over their niches.
They have a nice moment where the last mammal, which is like a little hamstery, hyraxy type thing.
Oh, and it's in the mountains.
And it's being farmed by these colonial spiders.
The colonial spiders, yeah. It's just fun, but they also back it up with like, here is why we think this might happen, and here is how this type of creature would have to adjust itself.
And they do it in a very Walking with Dinosaurs way, where they're describing it as they're seeing it and saying, the ancestor to these were this, which had this feature, which has been adapted to this use in this new animal. And it's very cool.
So it's like you said before, it's not just making up animals, it's saying what would be sensible. You can't predict evolution in the large scale like that, but what is an actual possible trajectory and how would it occur?
Absolutely. The alien planet is, we send very advanced probes to a planet that we identify as being very likely to have life with our future telescopes and readings, and send these probes there to search out, document life, and potentially find if there's any intelligent life. And that one has a little more just like creating interesting scenarios, but then explaining it biologically. And so there's not quite as much build-up, since we're not dealing with animals we know. We're dealing with an animal that has nothing to do with our animals, but then explaining, why is it this way? How is it surviving in this alien environment, and how is it biologically doing it? My favorite one is a flying predator that swoops in and stabs animals and drains them of their fluid and blood, but it is jet powered with these big like siphons, like an octopus, that it pumps air through and continuously glides itself by pumping air.
Oh, that's cool. Once again, based on an actual thing we have in the real world, an animal that pumps water.
Mm-hmm. And so, and I can't remember if they changed the gravity on the planet. It's been a while since I saw it. And then finally, the Dragons documentary is doing what we talked about at the end. It's taking, they make the point, almost every human culture has a story about dragons. And while we've never found any evidence that they actually exist, what if they did? How would these things that have so dominated our collective cultures, how could they have actually functioned? Why would they have the features we often show them having? And what would be the evolutionary history is the fun part. It starts during the Mesozoic with dragons during the time of dinosaurs, and then moves it forward and shows a couple of different lineages and how they eventually developed wings and 4 limbs through a mutation in the limb development, and then reduced wings and serpentine to become aquatic, which eventually gave you the Chinese and all that cool stuff.
Yeah, they also come up with biological explanations for things like fire breathing.
Yep.
And they had them, I don't remember the full details, but they would like chew up certain minerals in mountainsides.
Yeah, so
that could ignite.
And they had a gland with basically a methane collector in their body for while they were digesting stuff, it would store this flammable gas.
Yeah, and they would ignite the mineral deposits on their teeth, and it would launch this fire.
It was very, very interesting. And so those are some purposefully educational forms.
Mm-hmm.
There's also a lot of just for cool entertainment times we've seen this stuff pop up. I'm going to let you start this unit off if you have any personal favorite examples.
Well, two comes to mind immediately. One, just because we were just talking about dragons, it always makes me think of Reign of Fire.
Yeah.
Because they came up with another explanation for how dragons could breathe fire. They had two chambers. If I remember right, it was two chambers with two different gases, like a bombardier beetle.
Like a bombardier beetle.
And you mix them and it ignites.
Yeah, on contact, the chemical reaction was fire.
When you watch Reign of Fire, go for it.
They
looked cool. They were cool dragons.
It's still my favorite designed dragon I love them so much.
When they breathe fire, you can see the two jets that come out of the opposite sides of their mouths, and it ignites out away from their face.
And it was such a cool explanation and interesting one that if you look at dragons since that movie, the Hungarian Ridgeback, Horntail. Thank you. The Hungarian Horntail and Harry Potter.
The Norwegian Ridgeback and the Hungarian Horntail, I believe.
Yep. That's why I was like, I know I'm flipping the names. Has two jets of fire, and the dragons in Game of Thrones show the dual jet.
Yeah.
And even the robot arm they use to spray the fire has two fire spouts to keep. So even if they're not mentioning it in these fantasy settings, it's suggested that it has similar fire creation, or just that whoever made those went, "Well, that looked cool," but that's a fun one.
My other go-to example is if you ask me what my guilty pleasure movie is. this is the first movie that comes to mind. There's this movie from 2001 called Evolution.
Yeah.
I love it so much. And the premise of the movie is that an asteroid lands on Earth and it deposits extraterrestrial life. And over the course of the movie, we watch that life go through rapid evolution. It's explained that they evolve super fast, and here's the trajectory of their evolution. And what they do is they basically assume that their evolutionary path will mirror that of Earth.
Yeah.
And so they evolve these slightly alien versions of familiar stuff. There are flatworms, then there are giant insects, then there are amphibious creatures, and of course it ends with something that's just basically a gorilla, like an alien gorilla.
The big blue no-nose monkeys.
Yes. Yep. And it's fun, sort of. They're less sciencey about it. There's not much sort of explained. There's a bit about selenium at the end that's very hokey. But they're kind of making this parallel alien trajectory to real world evolutionary history.
The two movie examples I had actually have a common thread. Peter Jackson's King Kong and Avatar are both really cool examples of ecosystems, both alien and Earth, created through a speculative evolution mindset.
Yeah, and he wrote books about.
Oh yeah, you can get whole books about the ecosystem of Skull Island and Pandora, and it's really cool. And they have some really cool ones. The one that I'm going to focus on is the Avatar one, because the attention put in there is never mentioned verbally in the movie, but there's so many cool connections. And even for one of my annoyances, they put a potential answer there. So on the world of Pandora, almost all of the major big life forms, what would serve the place of mammals in many of these roles, have 6 limbs, smooth skin, 2 antennae with those little twirly light bits that you connect with, multiple eyes.
The little mating coils.
Yes, the mating coils. the USB cords.
Yes, exactly. Yeah, exactly. That's my HDMI cord.
And this is one of the more interesting ones that they keep very consistent. Breathe through their chest cavity, not through their face. Straight into the lungs.
And they're consistent as though these are ancestral features.
Yes, that this is a common feature across this branch of life on the planet. One major exception are the Na'vi, the main character aliens, which are just big cat people. Which, from a movie-making point of view, it's hard for our main character to have a loving relationship with a four-armed, lizardy-eyed person. I can see why the artistic licensing aspects stepped in on that one, but even though they now have 4 limbs, 2 eyes, breathe through a nose, and only one tail conveniently hidden within a ponytail, there's actually one organism on the planet that the fans have pointed out, it's never mentioned, but is pretty obviously their answer for this is the transition. And it's called the Prolemurus. And you get one glimpse of them in the movie where they swing through the trees and one of them stops. And they're a little bit different. They no longer breathe through the chest. They have a nose. They have only 2 eyes now. And they have that ponytail antenna. But the part that really makes it interesting is instead of 4 arms, they have 2 limbs that split at the elbow.
Oh, yeah.
And so
they put in a potential ancestral analog.
Potential evolutionary step. And yeah, it's not perfect, but the fact that they even put that in there means that someone on the making of the movie went, guys, it makes no sense why there'd be cat people.
Well, and I remember that movie, because this was 2009, I think. Avatar.
Yeah, when it broke all the records.
All of the records. James Cameron broke his own record.
Yeah.
From 12 years earlier, which, by the way, that first one stole the record from Jurassic Park. I remember watching that movie and coming out of it, and this is that speculative evolution mindset that we were mentioning before. I came out of it going, why do the Na'vi and the Banshees only have 4 legs?
Yep.
This bothers the heck out of me. Like,
yep.
Why did you do this? And the fact that there's a hint of a response in there somewhere is really, really nice.
It's because it's not a documentary, but the fact someone put major time and effort into trying to make this world make a portion of sense when scrutinized from a scientific point of view, and that's so cool. I made the movie much higher on the list than it. I mean, it's a great movie, but it is higher up than it would just be without that, for me personally.
Another example, maybe our listeners have already keyed in on, but that question of what if the dinosaurs never went extinct was tackled in a recent Pixar movie.
Yes, it was.
The Good Dinosaur, where they ask the same sort of question.
And it's a kids answer to it, but they still have some interesting little touches in there. I really like that, like, the pterosaurs have redeveloped their fingers on their wings to be more grasping and stuff like that. Like, little cool things in there.
Yeah, so some movies take a very scientific approach to it. Some hint at it. Others kind of just throw off. Like, every now and then you'll get those people like Ridley Scott.
Yes.
Who get into that, what is the history of this creature I've created? Or the fans do it.
Yeah.
Even more commonly in things like Star Wars and other fictional universes. So there's this whole range of how seriously people take it.
There's whole comic book series where they go to the home planet back before it was established in movies of the xenomorphs, the aliens from Alien, and you find out what their role in the ecosystem is there. They address one of the observations the characters make in the first movie of what kind of defense must you be what must you be defending again with a defense like acid for blood?
Yes.
and they put in an ecosystem that would make sense for why would you have colonial organisms this terrifying? The rest of the wildlife must be even tougher. And it's cool stuff like that. Even sometimes, like with both Avatar and King Kong, a lot of the animals are just monsters. So even when they succumb to monstrification, they can still be very interesting for speculative evolution. So it's very cool how it can work into stuff.
And even that, we mentioned this, I think, in probably episode 23, that trope of the lost world in movies, of the land where time stood still. Skull Island is one of those. The plateau in South America in the original The Lost World, also in Up. That idea of what if there was a part of the world where old stuff stuck around, right? The Savage Land in the Marvel universe is one of those as well. Is another form, often not tackled very scientifically. Usually it's an excuse to just put all our favorite prehistoric creatures in the same place.
Yep. And there's book series, the Meg series and Chronos Rising do the same thing. And once again, it's mostly just a reason to have your favorite paleo animal do cool stuff to people today. One good example of that I'm sure we were both thinking of most of this time is a TV show from across the pond, as they say, called Primeval.
Yes.
Some of you may or may not be aware of this show. It's kind of under the radar, kind of well known. It's an interesting little gem. Concept of this show is that suddenly these glowing, crystalline-looking portals are opening up and allowing organisms from other periods in Earth's timeline to pass through.
Yes. Which, again, is an excuse to... We have a Tyrannosaur in the airport, or it was a Giganotosaurus, I think, in the airport.
Yep.
We have a mammoth on the highway. We have stuff like that.
And it's an episodic creature of the week kind of show, mostly past, but once or twice in the first season and then more in the later seasons, they introduced the fact that, well, life doesn't all die off after tomorrow, so what if things from the future are coming through? Yes. And so every now and then they get these seeming monsters that are actually future evolutions of creatures today.
And
some
they
of them
actually
are really cool.
Do put in the effort to say,
yes.
All right, what if this monster creature is descended from... So the example we were both thinking of before, what if bats became large terrestrial predators?
Yeah, as they name it in the show, the future predator.
Yes.
And this is an organism that has lost its wings, walks on all fours, has reduced digits, and has lost its eyes completely and sees by echolocation.
Yes. So it's like the predator hunting through echolocation.
And they make them these simian-sized, ape, probably not quite gorilla-sized, very agile, fast-moving predators. And they
still have bat faces.
Yes, they still got big nose in the center, and it's really cool.
Someone put some thought into that.
Mm-hmm.
Like, what if bats became... We want them to be this specific kind of monster.
Yeah.
What would they look like if bats became this specific kind of monster?
And there's a couple of others. You get one that the wiki named the Myrrh, which is this seal walrus kind of thing. It sheds its skin much like walrus do, and it's this aquatic mammal of some sort, but seemingly has very human hands, and they don't connect it like through genetics, but at the end they're like, hey, for all we know, that could be us. Like, we don't know what humans become, and they have these interesting creatures.
Well, you mentioned, and I think this is a really interesting point, they do make it a focus in that episode to say they shed their skin like walruses.
Yes, they do. They show that's one of the things they find before they meet the creature.
Like, they're not just making stuff up. They are basing on biology, which is a key part of speculative evolution. You're not just coming up with some crazy thing off the top of your head, Gygax style.
Yes.
You actually, at least a little bit of biological thought went into it.
It is so much fun. It is the equivalent of throwing us paleontologists and biologists a bone in a movie and stuff when we get to see that. And when it's the focus, so good.
There are also video games that have tackled it. We mentioned Spore, which kind of skirts the edge of it, but there are plenty that, like, there's a whole history to, for example, the Zerg.
Yeah.
From the StarCraft universe of traveling around the universe, assimilating other organisms' features, many of which are based on real biological things we see in the world.
And so, like, each of the Zerg is based off an actual other alien species that they have, and they can have the histories before. Then we saw this form of the Zerg arise, and then we saw this form of the Zerg arise, because it progresses through as they adapt and develop.
And the Zerg are fun because when you play StarCraft, the gimmick with the Zerg is that they don't have any inorganic units. So, like, their spacecrafts are also living creatures, and just what would that look like, and how do you get to that? It's fun. It's all so that all this fiction talk is a lot of fun.
Now, while we're putting in suggestions for cool things, I do have to say that if you want to learn something if you want to look at something kind of like the Zerg, but better, you should look at the original, which are called Tyranids from Warhammer. I just have to.
This is all slide that in there. All lies. check out the Zerg.
Tyranids are way better.
The classic Zerg classic.
Classic 2.0. Now, this is all of the cool, fun stuff, but there are aspects of this that go into our hard sciences and can actually affect how we do science on our day-to-day. So, we've discussed now for quite a bit the just fun, cool concepts that can be done with speculative evolution, but there is a practical side to it, and it has come in use within science in a number of ways. We've mentioned that it helps with critical thinking, but to give some more specifics, we'll focus on two: how it affects paleontology and astrobiology. And for paleontology, or as it's sometimes called, speculative paleontology, it is very important to be able to go through this process and try to answer, why is this thing that we're looking at the way it is? And how did it get that way?
Yeah, the same skills that you use to be like, all right, if your endpoint is Charizard, how do you get there? Same thing when we go, all right, Stegosaurus.
Yeah.
What is that doing? How do we get there?
And now, there are obviously scientific and hard research data ways to come to that answer, but you have to know what questions to ask, and thinking up those questions often uses the same skills as speculative evolution, going, okay, so this bone is obviously this bone, which means maybe they were using it like this?
Mm-hmm.
So how do we test that?
Yes.
And figuring out a way to test. Hypothesis is the start of it, and speculative evolution is all about hypotheticals. If blank was doing blank, how would it look? If this looks this way, how is it being used?
Yes. If this is the trajectory that this lineage took to get here, what would we look for in the fossil record to confirm that? How would we test that hypothesis?
We did a news piece a while back about ceratopsians and their ornate frills, and thinking that maybe it was for identifying between individuals. Now, the science that happened after that is just straight paleontology and research. But coming up with that idea is speculative hypothesis of going, okay, they all look different. We can tell that. Maybe they could tell that too. You know what? Maybe having so many around could actually get confusing for the animals. I could see that. I'd get confused if a bunch of people all looked like me and I was trying to tell who my brother was. I might want my family to wear specific hats. Yeah. That concept of thinking through a less than obvious answer and then figuring out how to test it. So that skill pops up in paleontology a lot.
Yes, it does.
Another one is interpreting fossils. So not just figuring out how did it develop or why, but what are you looking at?
Yes.
There's a lot of fossil organisms out there that are not clear for how they were functioning and were put together. The famous example being like the iguanodon originally had its thumb on its nose because a spike is most likely a horn.
Yeah, Anomalocaris was identified as 3 separate organisms because the different parts of its body are so weird.
Absolutely. And so that kind of stuff is where you have to start getting creative and figuring out, okay, how does this fit within a body? Or what does the rest of this body look like? And there's some really good examples of doing that in speculative evolution, and also some examples of what not to do. One of these that is not quite speculative evolution, but more of that speculative biology, is over examples of shrink wrapping. And this is something I'm sure if when we do a paleo art episode, we'll talk about shrink wrapping more. But this is the concept of not giving enough room between muscle and skin for tissues like fat and fibers and other body parts that would be in there.
Yeah, there's a long-running trope in dinosaur art, and all paleo art in general. You'll see them like popular dinosaur depictions with the skin is so tight over the skull, you can see every feature on the skull.
Mm-hmm.
You can see the antorbital fenestra, right? That dip in the skull right in front of the eyes, and that There are some animals today where in some places the skin hugs very tightly to the
Alligators and
skull.
crocs, it's basically skin to bone.
Yep. But if you've ever held a rabbit, like, that's a super tiny little body that does not look tiny on the outside, because there's tissue, there's skin, there's fur, there's all sorts of stuff that can pad the face and the rest of the body.
And to kind of make this point that this is something we need to be careful of when trying to display what a fossil creature looked like, some artists have speculated how modern animals could be interpreted if they were shrink wrapped like we shrink fossil ones.
It's one of my favorite sections of All Yesterdays.
Yep. And so there's a bunch of things like swans and whales, baboons probably my favorite, and cats. If we shrink wrapped them, how vastly different they would look.
And speaking of All Yesterdays, I think we've mentioned this book on the podcast.
I
think we mentioned it in the survey, the Q&A episode, actually.
Yes.
All Yesterdays is a fantastic example of how you can apply speculative evolution ideas and processes to real questions about paleontology. The whole purpose of the book, it's Darren Naish, who we mentioned before, along with C.M. Kozman and John Conway, and it's all art explained in various, okay, we don't have an answer to this question. What were these arms for? How did this animal move around? What is possible? Here's some art about it.
Yes.
The cover of the book is a bunch of small ceratopsians in a tree.
Yep. Which I love.
And they make the point, anatomically, there's no evidence for that.
Mm-hmm.
There's nothing about their body that would make us think they climb trees, but there's also nothing about a goat's body that would make you think it climbs trees, and there are tree climbing goats.
Yes.
We're not saying that this happened with these ceratopsians, but it's possible. This is an actual possibility based on modern biology.
With modern animals, the same thing happens, where the knowledge that alligators live in freshwater, crocodiles live in saltwater is very common among a lot of people and completely misunderstood. Crocodiles do not live in saltwater. They can drink saltwater, but they're mostly across the world found in freshwater. Most environments that you find crocodiles in are still rivers and stuff, because if you don't have to drink saltwater, why would you? And alligators cannot drink saltwater, neither can caimans. But big alligators are found on the beach all the time. They've been found with barnacles on their back, because if you're big, you can handle salt longer, and if you're in the ocean, you're not competing with other alligators, and there's different food out there, so why wouldn't you? Same fact that, like, cows and deer are often known to eat baby birds.
Yes.
Protein and calcium. And so these kind of examples of speculative evolution are a great way to remind people that it's like, hey, animals do things you don't expect them to do all the time.
One of my favorite artworks in All Yesterdays seeks to answer the question of how stegosaurs mated.
Yes.
And it's wonderful. There's some good stuff answering all these questions. And then, like you said, there's a whole section in there of how might we have misinterpreted modern animals if all we had was their bones, which is a fantastic thought experiment.
Yes.
Not hard science, or at least, it's not like hard evidence, it's not hard data, but in terms of encouraging paleontologists and biologists to consider these things, consider what are we missing, what are we not thinking of, these are really, really excellent thought experiments to consider.
I've seen the similar thing done from an archaeology standpoint of how would future archaeologists, human or otherwise, interpret the things of our modern world. For
Yes.
a people or a race that no longer uses toilets, what would they think a toilet was?
I'm so glad that was the example I was about to
Yep.
use. The porcelain altar.
Yes, the porcelain altar,
Yeah.
where they
Every
worship.
home has one of these
Obviously.
as the shrine.
And, I mean, there were buildings with dozens of these.
Oh, yeah.
Incredibly important to our culture. And so these kind of concepts are really important for reminding us and exercising those thoughts. Some more hard sciencey examples is interpreting how unknown ancestors, unknown fossil individuals might have looked. There's a article, I'll link it in the blog because it's got a really great article and picture to it, is a picture of the earliest modern mammal ancestor, which we do not have a fossil of. And it is fascinating because as the article goes through, the artist worked with 23 scientists who compared over 12,000 pictures describing ancient and modern mammals and their features and their anatomy and their shared traits, and tried to determine what features the earliest modern mammal most likely had, so that artist Carl Buell could draw this unknown organism that does not even have a name yet, nicknamed Darwin, I think, in the artwork.
Well, yeah, we've mentioned this before, this idea of ancestral state reconstruction.
Yeah.
Where you infer what were all the ancestral features of a group.
And that's all speculative evolution backed by real science.
Yes, so I assume this modern mammal had descended testicles.
Yeah. I'll have to double check. I'll have to.
We'll have to lift up its skirt.
We'll write Carl.
Yes, dear Carl.
I noticed you did not draw this, but if I were to have moved that leaf in your picture, could you tell me what I would have seen?
There have been a scrotum or no?
Yes. The other example, and this is one of my favorites, is predictions. Every now and then, very, very rarely, and not always on the nose, but every now and then, speculative evolution has actually thought of a behavior or morphology for a animal or a group of animals before that was actually discovered. I have two examples. One is from Dixon in New Dinosaurs, where he suggested that, much like we mentioned with bats earlier, there are flightless birds. Why not flightless pterosaurs? And these long-limbed, long-neck organisms, if flightless, probably walked around like a giraffe. And drew these giraffoid pterosaurs. Back then seemed ridiculous, based on some hypotheses. This was not him just thinking off, that he was going off of current science at the time. Not all of it popular science at the time, because that's kind of the point of the speculative evolution, is going a little bit on the fringe and going, okay, we've all thought of them using it this way. What if they were using it a different way? What are the other options? This was one of those. Now, we have not discovered for sure how these big pterosaurs looked while walking around, but that reconstruction of striding pterosaurs is now fairly common in paleoart, because
the terrestrial pterosaurs.
That stilt-legged, big-beaked, potentially ground predators even. And that's an idea that came up through pure speculative evolution in a book just about it for the sake of it. The best example, the coolest example. This is just fascinating. Artist John Meseros I'll link his site on the blog, has multiple fictional paleoarts, speculative evolution paleoarts of potential fossil organisms that could have survived during different periods in Earth's history. So another form of a certain branch of life. One in particular that gained some notoriety is in 2013, he created the fictional creature Setimimus.
Mm-hmm.
Barbus being the species name. Setimimus barbus. The bearded Setacarius is what that means. It's actually featured in All Yesterdays. And basically the idea for this was an anomalocarid, the ancient group of arthropods, ocean-going, that really, diversified during the Cambrian and formed large predators and smaller organisms and all up and down the food chain. But we hadn't found at the time any large filter feeders, to which John here said, why not? Almost every other era of the ocean has large filter feeding creatures. We have whales and manta rays and sharks today. Why wouldn't there be a big filter feeding anomalocarid doing the same job? And so he drew it. The bearded aspect of this creature referred to the long mouth bristles off the two mouth parts that acted like the baleen of a whale to filter out small organisms in the water. And then 2014 came along, and we identified the first seemingly filter-feeding anomalocarid.
It's very cool. It's a cool and common trend for scientists to say, shouldn't this exist?
Mm-hmm.
And then find it. And that's speculative evolution.
And it's important because it's not so much that this, makes a decision to where we're going, oh, that is a cool idea. We will describe this animal this way, but it gives us a moment to go, you know what? That's a good point. We should keep our eye out for that and keep our eyes open.
The big example that always comes to my mind, very famously, is an example that Darwin himself came up with. Darwin very famously, in I think the 1860s or so, came to know of a particular species of flower that had this extremely deep shape to it. These long, long petals, and the nectar was nestled way, way, way deep down, like these many, many inches down into the flower.
Into the tube.
Yes. And Darwin looked at it and predicted that there should be an insect out there who has a ridiculously long proboscis to reach in there, just based on, how organisms co-evolve with each other. And decades later, we discovered the butterfly or moth, one or the other, that has the specifically very long proboscis to reach into that flower and get the nectar out. The guy who started the whole thing,
yes,
did it himself. Another example is in the 1980s, I believe, is when paleo artists first started drawing speculative dinosaurs with feathers on them.
Yeah.
Because we kept discovering all these other bird features, as we discussed in the episode 37. A lot of the features we associate with birds, more and more we were finding they actually started before birds showed up. So some paleontologists started saying, maybe feathers showed up before true birds did. And lo and behold, in the 90s, we found out that absolutely, they definitely did.
Now, one area of science that speculative evolution is arguably more important and more often used than anywhere else is
rampant
astrobiology or xenobiology and exobiology. You'll see it with a number of names, but this is, as we discussed in episode
26,
this is the scientific search for the origin of life on Earth and the presence and origin of life on other planets.
Yes, aliens.
Trying to answer, how does life develop on a planet, and has it developed on other planets? The trick is, we haven't discovered any other alien life yet, so we don't know what it might be like, and that actually makes it hard to look for. We discussed this in our astrobiology episode, that assuming that you're going to find something walking around and on an alien world could be completely off. This is a planet with its own geochemistry, with its own potentially type of star, its own orbit, its own atmosphere,
its own gravity,
all of these
things. Other
things.
Organisms.
Yes. And so why in the world of that world would you assume these organisms would develop just like Earth's? Why would that be the logical conclusion? And one of the answers is that probably it wouldn't.
And this is one of those bits of sort of semi-lazy, although justified, storytelling that goes into a lot of fictional alien races. As we've commented on before, is that intelligent alien races in most fiction tend to be bipedal organisms with mouths and eyes on the fronts of their faces.
And only require a few prosthetics stuck onto their face to be acted well by Hollywood stars.
But would they?
Yeah, why?
It's very interesting to then speculate, not only at that sort of alien level, like xenomorphs and
what
Mars
other
attacks and such.
Body shapes could we have?
But also in just how would it start and what would the very beginnings of it look like? And would you get similar forms?
Does it use DNA? If it doesn't use DNA, or if it's not carbon-based, or if it doesn't use water, what else could it use that serves a similar function? Now, we're still limited because we only know one planet's worth of life. But there are things on, if it's not a water-based life form, what other fluids could act as a solvent. Things like hydrocarbons and ammonia. And these are science things that we already know that these are similar to water, but by going through and finding out which ones serve a similar role in the body could give us new ways to look for life. If we know that hydrocarbons are really, really similar to water and could do very similar jobs in a slightly different cell, maybe we keep our eye out for hydrocarbons when we're looking on a planet.
Yep.
These things can give us those clues of this might be something to put a pin in if you find it, because that could mean we have an alien life functioning like ours, but with different ingredients.
Yeah, different chemistry.
Yes.
This actually was hinted at in Evolution, the movie.
Yeah.
As I mentioned way before, it's sort of a goofy way to do it, but they like, if we're carbon based and they trace down the periodic table.
Carbon is to arsenic as
yes, as what were they, silicon based?
I think
is to selenium.
Yep.
And it was just space on the periodic table.
It's
now,
high school
fair,
analogy.
There is a reason that chemicals are spaced the way they are on the periodic table.
Absolutely.
I've never actually spoken to a chemist about how much sense that makes, but they're getting at the same thing, right? If you're based on different chemistry, how will you interact with other chemistry? What will you leave behind? What will you require to live, and so on?
There's also the question for where could life truly be living? We assumed long ago that life needed water and sunlight. And then we discovered environments where it did not need sunlight. So we still have yet to discover life without water on Earth. But you have things like extremophiles that have showed us that life can live in very odd environments. So for this, you have to look at these potential planets that life could be on and ask what might be able to survive there and how would it be surviving. Instead of saying what other things could life be using, on the moon of Titan, there are hydrocarbon seas. Not of water, but hydrocarbons. Could that sustain life? If it did, what would that life have to do to survive in a hydrocarbon sea?
Yes, what would it take to evolve life in this place?
Different atmospheres, extreme orbits. You get some planets that their orbits change in their distance from their star. Or you get weird systems where there are multiple stars orbiting each other with planets orbiting the stars. How would having 2 or 3 sunsets work? And so, there's definitely, we typically only consider life on the Goldilocks planets where liquid water can form. But there is the benefit to asking, what about all these weird ones? What really are the limits of life? Now, most of these questions probably won't be answered in any of our lifetimes.
Yeah.
But asking them can help us think of ways to look at these planets that we might not have before.
Yeah, again, it's even if most of our speculation is wrong, which honestly it probably is.
Most likely is.
If it guides us to ways to search, ways to look for those answers, you can't rule stuff out if you can't test for it, and you can't test for it if you didn't think of it. So it's a useful exercise.
Now, we are almost at the end of our episode, what may end up being a longer episode.
The episode where we're encouraged to talk about popular media and films and TV. That one's a long one.
Who saw that coming? There are some pitfalls or limitations that should be considered when doing this that could potentially be issues, or could be crutches aren't the right word, but kind of traps to get stuck in. Limited perspective is probably the one you see pop up most often, where people suggest, this is what this animal could have looked like if it evolved to fly or to swim. And really they're just making it the shape of another animal, because when I think of swimming, I think of dolphins, so I'm just going to make a lizard dolphin shaped because, whatever it may be. Probably the most rampant example of this, as we mentioned, the intelligent alien, but also any intelligent animal. Most times when you see sci-fi things where it's like, oh yeah, but then dogs developed intelligence and suddenly started walking upright for some reason and developed thumbs too.
Yep. That's always like, what if birds became hyper intelligent and then you just have humanoid birds, because that's our narrow vision of what intelligent organisms look like.
Which for a fantasy world can be tons of fun. I will play Dragonborn in D&D as often as I possibly can. But there are times where it's kind of gone awry. Probably the most infamous example is the Dinosauroid.
Yeah.
This is a conceptual idea put forth by Dale Russell in 1983 of what if dinosaurs had not, the non-avian dinosaurs had not gone extinct and had developed hyper-intelligence like us humans, human-level intelligence. He put forth a design, a sculpture of what it might have looked like. He used a Troodon, a two-legged predatory dinosaur, as an example, as his
starting point.
Thank you.
Ancestor. Well, because at least at that time, and maybe still now, Troodon had the highest, what is called EQ, encephalization quotient.
Yeah.
Of all dinosaurs, which is the ratio of the size of the brain to the size of the body.
Yeah, so big brain dinosaur. So at the time, it seemed like the most likely candidate to become super intelligent. And the model he formed is bipedal with grasping hands and thumbs now. The three fingers have formed into two fingers and a thumb. Binocular forward-facing eyes, a short snout, and a large bulbous cranium.
It's just a blue human.
It's just scaly human with kind of a beak instead of lips and less fingers. Which, if that was in a RPG video game, I'd absolutely play as that. That'd be tons of fun. But there's no reason for us to think that dinosaurs would take a human shape, especially since we already have ape-level intelligence dinosaurs today. They're called crows.
Yeah.
And they have same brain to body ratio as a chimp and are problem solvers with use tools, remember complex things like human faces, and can communicate them to future generations. Like, we already have hyper intelligent dinosaurs. They look like birds.
And that's something that speculative evolution often does fall into, that pitfall of assuming inevitability.
Yes.
Assuming an end point. That's another one of those big questions. People always, I see this all the time online. What people say, if the dinosaurs hadn't gone extinct, would they have developed a hyper-intelligent species? As though that is an automatic endpoint.
That's the goal. I mean, that's
the goal somehow.
Going back to Spore, that's the goal of the game. Get to space.
Yes. And that it's easy to fall into that assumption of a goal, which evolution, by definition, does not have an end point. It's not aiming at something. Now, of course, you just did, in fact, give the answer to that question. What if the dinosaurs had evolved a hyper-intelligent species? They did. They're using our cars to crack their food open.
Exactly. And so it's real easy to get stuck and to ignore the obvious answer sometimes that may already be sitting in front of you. This can be misleading because this dinosauroid gets brought up by news sources kind of regularly as, oh, this is what scientists think dinosaurs may have evolved into.
Yeah.
No, we don't. No, they don't.
Well,
I think two guys did.
Yeah. That's another thing, is that it can be very easy to either come up with an idea that sticks in the minds of the public. For example, the idea of a frilled venom-spitting small theropod has never been scientifically accurate, but ever since 1993 has been all over the place.
Yep.
This has happened with over-exaggerated artwork. The famous case of Nebraska Man, which was a single tooth found in Nebraska that I think Osborne looked at it, said, looks like an ape, published it real quick, and then some artist in London was commissioned to draw a human species, like ancient humans, that based on this single tooth. Completely speculative notion that a single ape tooth meant ancient humans, and tooth turned out not even to be an ape.
And when you're an artist who's commissioned to do something, that's your meal. That's what's going to feed you. So you draw,
and that became a famous thing. Nebraska Man, this famous thing that was based on almost exactly nothing concrete.
And that kind of leads into the last question that we will end this episode on is, Is there a danger to speculative evolution? Is there a threat that it could distract from real science or get us stuck in the reeds, as the saying goes? Could this actually lead us away from looking at what the actual science is saying and get too stuck in what makes sense in our heads or is a really cool idea? There's some arguments to be made there. Things like Nebraska Man, things like coming up with a cool behavior, such as Pachycephalosaurs butting heads, which is highly, highly debated among those who study the fossil evidence, but it sure is a dynamic image. That's speculative evolution of behavior.
Yeah.
That's a hypothesis of what it might be happening, and yet most of the times when those animals make an appearance in anything, that's all they're doing.
Yeah, it's become a trope.
Mm-hmm.
It's caught on. It's that speculative idea that has supplanted reality in a sense. That has become this is what they did. And I think it's interesting that it really just falls into the same category as any scientific misrepresentation. It's the same reason half the world now thinks Velociraptor was a 6-foot-tall dinosaur.
Or that Megalodon is either fake or still out there.
Yes. So I think I don't know that that's an issue unique to speculative evolution.
I'd agree.
I also think, because there's that argument, this is a waste of time, this is a distraction. There's also something to be said. I don't think you're ever gonna stop it.
No.
This is imagination. Like, there will always, like, if you told me I could never think of a fictional creature again,
yeah,
you're out of luck. Like, that's not gonna happen.
We shall have words.
Yes. I think that it's just a natural part of curious human nature to come up with hypotheticals and play with maybes and predictions. I think it should be done responsibly.
Yes.
I think you need to be careful with, you shouldn't be publicized. That's like when the whole Nebraska Man thing,
mm-hmm.
Osborne himself supposedly saw the picture and went, "What did you do?" Like this,
yes.
All I said was it was an ape tooth. Like,
yeah.
You've gone completely off the rails with this for the sake of a headline somewhere.
I still think the benefits to speculative evolution, both for fun and for exercising our minds, vastly outweigh the threats. But I would like to offer to our listeners, if you have something to weigh in on this, if you have an opinion on speculative evolution, do you think there are threats? Do you like it? Do you have a coolest version of it you like? Because we'd love to hear it. I would love to hear if other people have annoyances with speculative evolution. If any researchers out there are not fans because they're tired of trying to fight against it. Because I'm sure there are times where it gets annoying when something about your research subject is popular but not based on research.
Well, it happens with all the Jurassic Park dinosaurs.
Yep.
Everything about Megalodon and mermaids.
Yep.
And also things like the aquatic ape hypothesis.
Yeah.
It's like an idea that speculation that becomes catchy. But yeah, do you listeners, do you have a favorite fictional example of speculative evolution? Do you have an example, like Will said, that you just can't stand, that is annoying or for some reason puts you off? Let us know. That'd be a lot of fun to hear about.
And since you mentioned them, if you're interested to hear more about things like mermaids and aquatic ape hypothesis, stay tuned.
Oh yes, please do.
But at this point, we're gonna have to wrap this discussion up because we are long-winded and have
what
we have. I sorry to break it to you. I've been meaning to have an intervention.
Yeah, this intervention is gonna go on forever.
it's an intervention that lasts 5 hours. Finally, someone goes, "Guys, I think we're missing the point."
Yes,
we're gonna wrap this up here. I love this subject. It is so much fun and so cool, and some really neat ideas get thrown out into the public eye for it. If you like this weird subject and you want to hear more like it or on it, let us know. As always, you can contact us in all the usual ways. We have email, we have Facebook, we have Twitter, and our Patreon and Podbean and WordPress. We'll put up the links in our blog post, which will be in the description. As usual, thank you for listening. Thank you to our Patreon patrons for funding us.
Yes, thank you to those who requested this wonderful topic.
Indeed. You guys, you all gave us a really cool subject to discuss, so
yes,
thank
as
you
can
again.
Tell, we had fun. And we release episodes every fortnight, so stay tuned for episode 40 coming up.
Yeah, we're turning 40, everyone. So stay tuned for that. Keep an eye on the channel, and we'll see you next time.
See you then.
Bye.
Thanks for listening to the Common Descent podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.